today we're going to talk about zeros and multiplicity, just an extension from what we did with our sketching last week. So if you recall, we can call our zeros lots of things. We can call them zeros. What's another thing we could call them? X-intercepts, solutions, and there's one more, roots. Very good. Okay, so our zeros, x-intercepts, roots, solutions, those all refer to the same points on the graph, right? Depending on how we stated it, we may write it differently, either in set notation or in ordered pairs, but basically we're referring to the same types of things, right? Okay, so this should be, most of this is kind of a big fat review plus just kind of bringing some stuff together. So what we know is the x-intercepts, okay, so we use that word, of a function are also called zeros. So we used that one. Okay? Polynomials, which we're talking about right now, a polynomial function of degree n can have at most n real zeros. Okay? So if I have a fourth degree polynomial, the most zeros I can have is 4. I may not even have 4. I may not have any, but 4 is the most I can have. All right? So we know we've talked about even and odd degree polynomials. An even degree polynomial has an even number of real zeros or no real zeros. An odd degree polynomial has an odd number of real zeros. But notice that one doesn't say or no real zeros. Why do you think an even polynomial can have no real zeros, but an odd one can't? Okay. Okay, yeah, I understand what you're saying. You have another. Because the odd goes in different directions, which is, I think, basically what you're saying, like this is negative and then positive. Odd has to be, the end behavior has to be opposite, right? So whether it's up, down, or down, up, I'm going to have to cross the x-axis. Here it crosses 3 times, but it could cross just once, where an even could look something like this. Oh, not like that because it can't be pointy. What am I doing? Could look something like that and not cross the x-axis at all. So that's why even could have 0, but odd has to have at least 1. Okay. We good with all that so far? Awesome. All right, so let's talk about linear factors and solutions. All right, so this is some vocabulary of some stuff you already know. All right, so these solutions, which, bam, we use that one, to the equation f of x, excuse me, equals 0, are the zeros of the function. They are also called roots. So there we go. We've used all 4 of them. Excuse me. If x equals c is a solution to the equation, then x minus c, which most of the times you're going to see in parentheses, but they don't have to be there if it's by itself, then x minus c is a linear factor. Linear factor of the polynomial function. So that's why if I have x minus c, so if that's x minus 5, I know x equals 5 is one of the solutions. And then linear factors can be found by factoring the polynomial. Factoring is super important for you to be able to do quickly and accurately. So we have this example that we're given. F of x equals x cubed plus 5x squared minus 24x. I'm going to factor this. When I factor, what's the first thing I always look for? GCF. Do I have one? Yes, I do. X times x squared plus 5x minus 24. Since a is 1 right here, I can go ahead and jump to, oops, I can't leave off my x though. I have my x, but then I can jump to parentheses here. I know this is going to be x and x. This is negative, so my signs are opposite. So I need 2 numbers that multiply to give me 24, subtract to give me 5. 8 and 3. Very good. Okay, so that is my fully factored form. We all agree with that? We're like experts at that, right? Okay. So then the linear factors, since this is factored, my linear factors are x, x plus 8, and x minus 3. Those are my factors. If you want to put parentheses around them in that situation, that's fine. It really doesn't matter either way. Then the zeros come from that, right? X equals, so I'm going to have a 0, a negative 8, and a 3. So I should have negative 8 first, negative 8, 0, 3. All that sound familiar? Okay, so again, some of it is just tying the correct terminology to what you already know how to do and kind of putting all this together. All right. So let's look at these. Let's look at number 2. So it says to find the zeros of the function below by factoring. So I want to make sure that we all understand when it is fully factored, because I think some of you still don't factor all the way and you think you're done and you're not. And for those of you that were photo math experts last year, you might need a little reminder on factoring once again. But again, this should be something that you've got to be able to do quickly and accurately on your own. All right, so I'm going to factor out my x. So I get 0 equals x times 2x squared minus 5x minus 3. So there are different ways to do this. I'm going to factor this by grouping. The majority of you, okay, A is not 1. So the great majority of you have no business jumping to 2 sets of parentheses at this point. Okay, now maybe that's how I was taught old school way, and that's the way that you should eventually get to. Maybe by the end of the year, some of you will be comfortable because you can just kind of see it then. Most of you, not there yet. Okay, so, and that's fine. I'm going to take this, since A is not 1, I have 2 times a negative 3, that gives me negative 6. I need 2 numbers that multiply to give me negative 6 and combine to give me negative 5. Negative 6 and positive 1. Now I heard negative 3 and negative 2 and then a no, like right after that. Is it logical that 3 and 2 pop in your head? 100%, because 3 plus 2 is 5. But then when you think about, well, when I multiply those two, I get a positive 6, so that's where your problem is. So yes, it'd be a negative 6 and a positive 1. Right? So now I'm going to split my middle term. 2x squared minus 6x plus x minus 3. Now I'm going to factor by grouping and not lose my x that's hanging out front. He's still important. I'm going to put brackets in here. That helps me because it's less parentheses. Factor out of the first 2 terms. I get a 2x. That leaves me with x minus 3. Then factor out a 1 here. That leaves me with x minus 3. Okay, even if you can figure out what your answers are right here, this is not fully factored. Okay, I go one more step and 0 equals x times x minus 3 times 2x plus 1. This is fully factored. Okay, makes sense? Right? So make sure you know when it is actually fully factored. So I have factored it, and then it says I'm supposed to find all the zeros. So do I put them in set notation or do I put it in ordered pairs? Set notation, yes. So x is equal to, my zeros are 0, 3, and what? Negative 1/2. So that one's going to go first. Negative 1/2, 0, 3. We've already found the zeros of functions. They weren't all necessarily polynomials, but we should be able to do that, but you got to be able to factor to get that done. Number 3, it's a quartic, right? It's a 4th degree polynomial. So second period, I said, all right, just y'all factor this. And of course, there were some people that just stared at it. You can't just these can't stump you anymore. Yes, this is a 4th degree, but there are 3 terms, and I can treat it like a quadratic. Okay, so we're going to do this one together, then y'all are going to do 4. So 0 equals, A is 1, so I can jump to the parentheses. This has to be x squared and x squared. This is positive, so the signs are the same. This is negative, so they're both negative. 2 numbers that multiply to give me 4, combine to give me negative 5. 4 and 1. There you go. Then can you factor this more? Yes, so let me ask you another question. Can I get my zeros at this step? I can, but is it fully factored? No, and right now I want you to have it fully factored. So factor it, you got one more step here. All right, and you tell me what the next step looks like. Very good. Y'all agree with that? Okay, so that is fully factored. Now from this, I can get my zeros. I could list out 4 numbers, which is 100% fine. And if you already did that, 100% fine. Nothing wrong with it at all. But instead of listing out the 4, Estella, can you tell me how else I could write it? Good. Plus or minus 2, plus or minus 1, or the other way, because, you know, which one's coming first, the positive or the negative? Very good. All right, what questions you got? So if you are working a problem like this, and it doesn't necessarily say, or I haven't said, I want you to fully factor it, and you use this to find your zeros, there isn't anything wrong with that, except that probably about half of you would only get 2 answers, right? Because once you take the square root, you got to remember your plus or minus. You are way safer if you go ahead and factor. You're less likely to leave out a factor, okay, or a zero rather. We good? All right, so let's look at number 4. On number 4, A is not 1, and it's a quartic, but you treat it like a quadratic. I'm going to give you a minute. I want you to factor this one. You can do it. You have already done it. That's fine. You should be able to fly through it like that. It's good. Yep. So you get that 36 and then figure it out from there. What are you doing? Are you making up math? Okay, 9 times 4 is 36. That's right. But then, so you need to find 2 numbers that are going to multiply to give you a positive 36 and combine to give you a negative 37 and split your middle term like we did up here. Okay. Holy hot mess. Let me just work through this with you, okay? But I will say again, I cannot continue to reteach factoring every time factoring comes up because it's going to come up so much. I do 9 times 4. That's 36. I need 2 numbers that multiply to give me a positive 36 combined to give me a negative 37. That's negative 36 and negative 1. I then use that to split my middle term. And I get 9x to the 4th minus 36x squared minus x squared plus 4. Now, one common thing I see in people that 100% know what they're doing is that you put the 4th here, but then you forget to put the squareds here, and then you just confuse yourself. So just be careful with that. But now that I have that, I can factor my GCFs here. So 0 equals, this would be 9x squared times x squared minus 4. Factor out a 1 here. That leaves me with x squared minus 4. 0 equals, and I have x squared minus 4 times 9x squared minus 1. Can I factor that more? Yes, I have 2 sets of difference of squares again. So 0 equals x plus 2 times x minus 2, and then 3x plus 1 times 3x minus 1. That is fully factored. And then my zeros, I'm going to do plus or minus again. So we'll do plus or minus 1/3 and plus or minus 2. What questions do you have? If you need more practice with factoring, then go practice. You have assignments in Delta Math that you can keep going back and redoing them, so it'll give you questions. You can practice it. You can know if you're right. They'll show you how to do it. You can watch a video, but you absolutely positively cannot ignore it. Okay? That's be a bad, bad thing for you. All right, so let's look then at number 6. So this is a third degree polynomial. I have 4 terms. So I'm not going to work it exactly like I did the rest, but what are my options once I have 4 terms? What's the process? Grouping. Yes, grouping. So basically, we had to get it to 4 terms on the other side to be able to actually get here. So I'm going to just group this. It's already done for me. So out of these 2, I feel like I could factor out, what, a 4x squared? That'd leave me with 5x minus 3. Factor out a negative 1, 5x minus 3. You finish that up. All right, Swazi, can you tell me what the step after this looks like? Very good, thank you. All right, so then after that, Alexa's not here. Daisy, can I factor that some more? Good, and that becomes? Very good. And then I still have my 5x minus 3, right? Very good. We all good with that? Okay, so then I get my zeros from this. I can have that plus or minus 1/2. And then what's the other number? 3/5. 3/5. All right, what questions do you have? 100% Algebra 1 and Algebra 2, by the way. So, yeah. Okay, so let's talk multiplicity, which is like the new pre-cal part, which is super easy, but you can't get there if you can't factor. So, multiplicity of a 0 is the degree of its corresponding linear factor. So it's the degree on the factor itself, like what we looked at when we were sketching the polynomials. We knew if we had a bounce or a wiggle, right? So we're going to find the zeros of the function and state their multiplicities. So we can't get to the easy multiplicity part if we can't factor. Keep that in mind. So we'll factor this one together and then just look at multiplicities. All right, so the first thing I'm going to do is factor out my GCF. That gives me x squared plus 10x plus 25. This is actually a special case. I'm going to factor it just like I've factored all the other ones, then we'll talk about the special case. So that's 0 equals x, and then since a is 1, I can jump to this. I got x and x. This is positive, so they're the same. This is positive, so they're both positive. 2 numbers that multiply to give me 25 add to give me 10. 5 and 5. So look, this one shows up twice, which means that I can write that as x plus 5 squared. Okay? So this is a perfect square trinomial, which means that if I take, to figure out if this is what you have, if you take half of this and square it and you get that number, then whatever half of that is what goes right here, and it's just that binomial squared. It's that easy. So if you don't notice that, if you don't know your special cases, as long as you can factor it and get to that point, you're fine still. Okay, so then it says find the zeros and state their multiplicities. All right, so my zeros are -5 and 0. So negative 5, and then I need to state its multiplicity. It has a multiplicity of 2, because that linear factor shows up twice. It's whatever the degree of that is, so the multiplicity of 2. And then my other one is 0. It has a multiplicity of 1. And that's it. Does that make sense? You see how easy that is? All right. I'm going to start you on number 8, and then you'll finish it. So first I look for my GCF, which is x squared, but I would really like for this term right here to be positive, so I'm going to factor out a negative x squared. That leaves me with x squared minus 6x plus 9. You finish that one up. Okay, so the other thing about special cases is since they don't always happen, you don't always think to look for them. But if you do notice it, like if I take half of negative 6, I get negative 3. And I square it, I'll get a positive 9. So I know that here I can just do x minus 3 squared, and that's the same thing. Again, if you didn't notice it, but you got x minus 3 times x minus 3, totally fine. Just make sure that you put them together and then make it squared. Okay? So then my zeros, I have a positive 3 and a 0. So I'll have 0 has a multiplicity of what? 2. And then the 3 has a multiplicity of what? 2. They both do. What questions do you have? Yes, it's because of this exponent right here. It's how many times does it show up? They're also called double roots. Yes, sir. As long as you put they're both multiplicity of 2. You know, as long as you use the word both or something. Otherwise, it's going to look like you just stated it on one of them. All right, anything else? All right, so let's look at our multiplicity and graphing, which is basically what we did last Thursday and Friday, but we're just kind of restating it and using some of the actual terminology and connecting it to the actual factoring. So it says we're going to write this function in factored form and graph the function. Okay, so I need to factor it first. I'm going to factor this. So when I factor this, I'm going to factor out the x first. That leaves me with x squared plus 4x plus 4. So then I can see that I can take half of this and square it and get 4. So then this would just be x plus 2 squared. Okay? So my factored form, f of x equals x times x plus 2 squared. So it says to graph the function. We're going to sketch the function, okay? And for that, I need my zeros. My zeros are negative 2 and 0, right? So I can make like 3 little hash marks here. So since negative 2 and since 0 is an x-intercept, it's also my y-intercept, right? What would the end behavior, let me get somebody to answer that for me. I want to know what the end behavior would look like from Brenda. What would the end behavior look like? Down, up? Do y'all agree with that? Yes? It's third degree, so down, up. Very good. Thank you, Brenda. So I got down, up. I know where my intercepts are. I feel like I can go ahead and sketch this in, right? So I'm going to start down here. When I go up, well, what's wrong with this? Where's the bounce? That's right. So what we already knew was, we know that, yes, I'm supposed to start down here, but we learned last week already that if I have a factor that has an exponent greater than 1 and it's even, then I have a bounce. What's the real word for the bounce? Okay, hang on, we'll get to that. All right, so let me show you what I did last period. Okay, this is my confessions of a bad teacher. So I said we talked about all that, right? I was like, all right, I'm supposed to bounce at -2. And then I totally did this. And I said, we all okay? Do you have any questions? And nobody said a word. And then we went on, and I caught myself as I was like, what? And somebody goes, yeah, I think you were supposed to bounce at -2. I said, yes, I was, and that's what I said, but that's totally not what I did. So if you think something's weird, speak up, right? So when you, and I see this from y'all too. I even marked it. I said it, I marked it, I still bounced at the wrong place. Okay, so just be careful because those are just brain farts that happen. So that was not correct. I'm supposed to bounce at -2. Come up here, I bounce, come back down, and it looks like that. Okay, we all agree with that? Because we know how to sketch. Okay, so if my multiplicity is even, that's where the bounce is, right? But that is when it is tangent, remember that now? Tangent to the x-axis. So it's fine to say bounce when we're going to write it out for ourselves, because when we're graphing, that's what's happening. I'm bouncing. But when I have to actually state it, it's tangent to the x-axis right there, okay? It does intersect the x-axis, because remember, intersections is what they have in common. It's not a passing through. So this graph does intersect at the x-axis. It's just at that one point, which is not exactly what my graph looks like, but you can pretend. Okay, then when the multiplicity is 1, like the x is, something does happen, but it's just boring. Yes, it intersects, but again, this is an intersection also. So we just say that it passes through. Passes through the axis at that 0. And then if the multiplicity is odd but greater than 1, what happens there on the graph? Point of inflection, very good. And that is our wiggle when you're graphing, so you can think about what's happening, but it is officially a point of inflection. What questions do you have? Anything? So again, we're just kind of putting all this, the algebraic part of this together, because everything we did last week when we were graphing, they were already factored for you. And we didn't call them multiplicities and things like that. So let's look at this. This says to identify these zeros, their multiplicities, and describe the effect on the graph. All right, so on number 9, it's factored for me. I can easily come up with my zeros. See, it's going to be 1, 3 halves, -4. So -4, 1, 3 halves. No, okay, can I factor it more? If it was x squared minus 1, yes, that's what you're thinking of. Okay, good question though. Yeah, if this was x squared minus 1, I would totally need to factor it more, but the squared's on the outside, so good question though. All right, so -4. So for this 0, what's this multiplicity? 1, right? 1. And what happens when it's 1? It just passes through. It's just a plain old boring intersection. All right, so then my 1 has a multiplicity of 2. And what happens there? I know it's a bounce, but what's our real word? Tangent. Okay, good. And then this one also, so my 3 halves, also has a multiplicity of 2. So what happens there? Tangent. All right. Number 10. You're going to have to factor that one. Factor out the GCF, then completely factor it, and fill in that little chart. I'll give you a minute to do that. You're fine. You're fine. Oh, you. That's because she knows how to factor. Exactly. We're all going to be able to say that soon. I'm just good at factoring. I'm good at factoring. That's what you need to tell yourself. That's good. Yeah. So it just takes you a second sometimes to come up with the numbers, but you know what you're doing. Yeah, yeah, there you go. She's good. She's just not perfect. Nobody's perfect. It's fine. So if they're bragging and I'm just kidding. All right. Is that what we got? Okay, good deal. So then this 0 that's in -4, V, what is that multiplicity? 2. V, what's the multiplicity? Yes. And what is the effect on that, V? Tangent. Very good. All right, so then my other 0 is 0. Ashley, tell me, what is that multiplicity? 3, and what's that effect? Very good. Point of inflection. All right, what questions do you have? We all good? Awesome. So you got a few minutes left. Get your device out, not your phone, and get to work on that delta math, because you could get a couple done in the next few minutes. Or if you need to get your the paper out from Friday and you have any questions on that, I can look over that, or you can finish that up.